Vitamins and minerals. Vitamin K. We will now review this vitamin involved in blood health. Vitamin K includes a group of compounds called quinones. We see here the primary quinones are phylloquinones, menaquinones, and menadione. The phylloquinones are naturally occurring in plants, and this is the form of vitamin K that we consume in foods. We see the three structures of the menadione, phylloquinone, and menaquinone, each containing this ring core. We see here the vitamin K content of selected foods, so these are going to be primary food products rich in vitamin K. We're going to see the most vitamin K rich foods are going to be dark green, mostly leafy vegetables. We see broccoli as a primary source, kale, Swiss chard, watercress, collards, spinach, and salad greens. Looking at the digestion and absorption of vitamin K, we see that vitamin K requires no digestion, and we see that it is absorbed in the jejunum as part of micelles. So just like with the other fat-soluble vitamins and other lipid products, we see incorporation of vitamin K within the small intestine into the micelles with other lipids, bile salts, cholesterol, and other fat-soluble vitamins. It is then absorbed through the brush border of the enterocyte, and then from there we see incorporation into chylomicrons, and then movement into the lymphatic system. We see that the menaquinones, which are synthesized by gut bacteria, are going to be absorbed by passive diffusion in the ileum and colon. But however, the primary dietary source that we are going to be consuming is the phylloquinone form. Looking at its transport and storage, we see that vitamin K, as we mentioned previously, once in the enterocyte, is incorporated with other lipid products into chylomicrons. And this again is going to be within the enterocyte, and so once the chylomicron has formed, it exits through the basolateral membrane into lymphatic circulation. From there it is transported through the blood to different body tissues. We see that the chylomicrons also will deliver remaining vitamin K to the liver for further metabolism. We see that it's metabolized by the liver or incorporated into the VLDLs for secretion back into the bloodstream. And this is again going to be similar to what we've seen for the other fat-soluble vitamins. We see incorporation into the LDL, lipoproteins, and also HDL. We see it stored in the cell membranes of extrahepatic tissue. The primary functions of vitamin K is going to be involved in blood clotting. Also, we'll see it involved in bone mineralization. The functions of vitamin K in blood clotting and bone mineralization is going to be primarily in its ability to be involved in the carboxylation of glutamic acid residues. And it is in its ability to be involved in this carboxylation, in that it plays its in the processes of blood clotting and bone mineralization. We see more specifically that vitamin K is going to be needed for the activity of the carboxylase enzyme. So again, that's going to be a vitamin K dependent carboxylase enzyme that's going to catalyze the carboxylation reaction. We see a specific protein that will be dependent on this vitamin K dependent carboxylase enzyme will be osteocalcin, also known as GLA protein, involved in binding calcium within the hydroxyapatite lattice. So that we talked about before, that calcium and phosphorus will be the main minerals as component of this hydroxyapatite that makes up in part the structure of bone. So we see here in this diagram this carboxylation reaction. So we have a general peptide and a glutamic acid residue on that peptide, and then we have the carboxylation of that glutamic acid residue with this vitamin K dependent carboxylase enzyme. So we see here the product has an addition, there has added this CO2, and then at this point that this structure can bind calcium. So the peptide with the glutamic acid residue, which has now been carboxylated, which can bind calcium. So there's different proteins that will then benefit from this new ability to bind calcium. One protein that we discussed was the osteocalcin, involved in bone mineralization. Other proteins involved in blood clotting also will then, when carboxylated, can bind calcium and have its attendant effect in various processes. So then we see that these GLA proteins, after being carboxylated, can bind calcium and then have certain effects in either blood clotting or bone mineralization. We'll discuss further the processes involved in blood clotting, and we're going to see a similar type of process where we have involvement of vitamin K, and then once carboxylated, then that structure is able to bind calcium and then continue with the remaining steps of the process. So we see to promote blood clotting, this compound fibrinogen must be converted to fibrin, and there are both intrinsic and extrinsic pathways. So we're going to talk about a component of this pathway, especially the component where we see the involvement of vitamin K and then calcium. And this component of this process is going to be particularly where we see the conversion of what's called prothrombin to thrombin and fibrinogen to fibrin, and we see that the formation of fibrin here is what is going to be needed for this process of blood clotting. So we see here in this slide the series of reactions needed to eventually produce fibrin involved in the process of blood clotting. So there are a sequence of reactions that lead to the production of what's called this inactive clotting factor X. And so vitamin K, and then after the activity of vitamin K in carboxylation, then calcium can also bind. So when we see the involvement of vitamin K and calcium, we see there the conversion of the clotting factor X from being inactive to then active. And so these proteins with the little a next to them is now indicating that they have been active. So we see inactive, and then after the involvement of vitamin K and then binding of calcium, we see the activation of this factor X. With the activation of factor X, then we are able to see the conversion of prothrombin to thrombin. And we see that prothrombin is also called factor 2. And then when activated by the activated factor X, we see conversion to thrombin, which is the active factor 2. So once we have thrombin, which is the active factor 2, from there we can have the conversion of fibrinogen to fibrin. And so for fibrin to have its effect in blood clotting, it will need to be insoluble. So we see this fibrin stabilizing factor, which converts fibrin from being soluble to insoluble. So we see this is a more actually simplified version of the reactions involved in the eventual formation of fibrin in blood involved in blood clotting. We will focus though on the specific reactions where we see involvement of vitamin K, and then after vitamin K allowing for the carboxylation of glutamic acid residue, then allowing the binding of calcium. So that's going to be their involvement in the activation of factor X, which then allows for the conversion of prothrombin to thrombin, and then from there allows for the conversion of fibrinogen to fibrin. We'll look at the interactions of vitamin K with different medications. So we see vitamin K being involved in blood clotting. However, there are several very popular medications that are involved in the thinning of blood, so counteracting the reactions and processes involved in blood clotting. And actually the mechanism that these medications will utilize is actually blocking the carboxylation of clotting proteins. So we saw that vitamin K is involved in these carboxylation reactions, and actually these medications block that carboxylation process. We'll look at the dietary reference intakes, it's specifically the adequate intake level for vitamin K. So for men, it is 120 micrograms per day. In women, it is 90 micrograms per day. And deficiency is not that common. However, newborns are actually born without adequate vitamin K levels. And so very often it's basically standard practice that newborns are provided a vitamin K shot with parental consent. And then also malabsorption syndromes may increase the risk of vitamin K deficiency as well as certain antibiotics.